Hello everyone. Today we are going to cover a very interesting topic, which is 5G. 5G recently has garnered some controversy despite people claiming it causes cancer, lowers life expectancy, and some even relate 5G as the cause of coronavirus. People were furious over the implementation of 5G, protests on the streets were taking place, and cell phone towers were set on fire, etc. However, these claims simply are not true and they are just a part of the conspiracy theory. Before we could make any claims about 5G, we first must understand 5G and its functions. 5G, or also known as the fifth generation mobile network, followed by 1G, 2G, 3G, and 4G networks. 5G has completely revolutionized mobile communications as consumers will be able to download movies in just seconds, along with high-speed uninterrupted gaming and video streaming. The benefits of 5G are faster speed, reduced latency, and increased network capacity. As a result, providing a more reliable and efficient data transmission experience. In technical terms, 5G is powered by millimeter wave, which allows 5G to operate on a new high-frequency spectrum between 30 GHz and 300 GHz wavelengths. With a broad frequency spectrum, 5G can operate in lower bands, sub 6 GHz as well as millimeter wave 24 GHz and above, which increases network capacity and bandwidth. Speaking of network capacity, Massive MIMO, which is also known as the Massive Input Massive Output, allows more signal to be transmitted by many users with the deployment of multiple antennas at both the transmitter and receiver, enhancing the quality, throughput, and increasing the capacity of the radio link by a factor of 22 or greater compared to 4G. In contrast to that, beamforming in 5G is a type of radio frequency management in which wireless signals is directed toward a specific receiving device. Beamforming arrays are inherently different from MIMO in that the multiple columns of the poles work together to create a single high-gain signal, improving the spectral efficiency by providing a better signal-to-noise ratio. A full duplex system is also a contributing factor in extending the network capacity, as it allows transmitting and receiving signals over the same frequency band simultaneously. Larger bandwidth means more data can be transferred across a network, which explains the high-speed data transfer 5G offered, up to 10 gigabits per second, 10 times faster than 4G. When a huge chunk of data can travel quickly between two nodes, transmission and response time are reduced. When operated, as a result, the delay between sender and receiver is significantly reduced, also known as low network latency. However, the short wavelength produced by 5G significantly impacts the range of data transmission. Signal strength drops off rapidly with distance compared to other bands. In addition, millimeter waves are also easily absorbed by atmospheric oxygen and water vapor. Therefore, small cells, portable miniature base stations that require minimal power to operate are being installed every 250 meters or so throughout the city to prevent signal loss through attenuation. In short, these are the 5G core technology: Massive MIMO, millimeter wave, full duplex radio, small cells, and beamforming. With 5G, a lot of things that were previously impossible have been made possible, such as the Internet of Things, automation technology, real-time remote access, and smart city and ports.
For next part, let's move on to the smart port. Smart port refers to an automated port that utilizes advanced technologies. The main reason why it is being used is it does not depend much on the human workforce and resources for functionality. There are few of uses of technologies for smart port, such as Internet of Things, big analytic data, digitalization, blockchain and robotics, makes the smart port capable of exceptional performance. The prominent features of a smart port are including an elevation in time efficiency, accuracy, and management, which means that smart ports are where technology and humans can share real-time information. The effectiveness of smart ports relies on human and technology working together to benefit the port and ultimately its customers. For further understanding, I will explain one of the example, seaport, which has adopted smart port to increase its efficiency. Seaports are referred to maritime facilities that can include one or more wharves where ships can dock to load and discharge cargo and passengers. In the early days, seaports are used to be only as a location to load or unload cargo from a ship, but for now, the role of the seaports are playing in the wider global economy. Therefore, seaports are now become the central to any manufacturer's supply chain plan and are ranked based on a number of aspects. The big data in the shipping industry is used for managing a ship's sensor and for predictive analysis, which is necessary to avoid delays and increase the industry's overall operational efficiency. In the shipping industry, properly tracking cargo is very important in maintaining the security and privacy needed. Besides, artificial intelligence (AI) can be utilized to strengthen shipping routes. It is because AI can determine the routes at the best speed. Moreover, IoT can help to lower the operating costs, enable real-time tracking, and also monitor the cargo. With IoT connectivity, the data insights will allow valuable data-driven decisions. Furthermore, blockchain technology can make the shipping faster, more efficient, and improve data visibility and demand management. It could manage and track the paper trail of millions of containers in the world. For 5G, it allows for connections of all kinds to be made. In fact, 5G will play a role in providing exceptional voice and data communications. Data transfer in real time will be faster, which will be beneficial for supply chain management, and all people involved in the supply chain will be connected. 5G signals will be much more reliable than the older types of cell signals. It has faster bandwidth with peak data transfer rates exceeding 1 GB per second. In transport layer, it converts the application layer messages it receives from sending application process into transport layer packets known as segments and transmit those segments into the network layer. The network layer will provide logical communication between the hosts. When the destination host receives them, the segment will then reassemble into messages and pass on to the application layer. Therefore, vehicle will receive them and can perform their tasks which are assigned.
Next, I will be talking about Automated Guided Vehicle (AGV) in SmartPort. AGV is a mobile robot that follows wire in the floor or uses vision, magnecs, or laser for navigation. It has an automatic guiding device with safety protection and various transfer functions. It can also control its route or use the electromagnetic path following system to set its route. What will AGV do in the SmartPort? AGV handling robot will become a new intelligent industrial equipment with real-time sensing, safe identification, avoiding multiple obstacles, intelligent decision making. Therefore, by using AGV, you will no longer find people working in the container terminal area. Everything has become automated. Therefore, the demand for high performance, flexible networking wireless network is increasingly for AGV systems. Network requirement for AGV, it requires low latency, large bandwidth, and also high reliability. With 4G, all these requirements cannot be fulfilled simultaneously. To implement AGV, 5G is introduced, with advantages, low latency, high density mass connection in factory application, high reliability and network mobility management, which will make the AGV system more efficiency. How should we implement 5G in SmartPort? Let's talk about one example. With a wide range of safety precautions, AGV warns the employee in dangerous situation by sending a notification to the central station. In this situation, reliable transmission is needed. In order to have reliable transmission, TCP is used because it is more reliable as the data can be received in a proper order. However, to receive data in an orderly manner, it needs to use the go back and data transfer protocol instead of selective repeating. This might cause time increment in the transmission in the case of packet loss, as we transmit the entire packet again instead of selecting the lost packet only. For reliable transmission, we will look into the two features of TCP, which are flow control and congestion control.
Let us look at the first TCP feature, flow control. The flow control means the TCP will ensure the sender do not send overflow data to receiving host to make sure they can handle all the data. The flow control is more reliable transfer method. It will control the sending side to the receiving side. When we send data over the network, this is normally what happens. The sender application send data through the socket, then TCP will route it into segment and hand into the network layer, so it will route into the receiving node. From the receiving side, the concept same as the sender side. The network will deliver the data to TCP and send to the receiver application and the copy of the data sent. Let us look at this part. The TCP store the data need the send buffer to send it, and receive buffer will receive the data. When application is ready, it will read the data from the receive buffer. In this case, TCP store the received data in receive buffer on central control station, then TCP will acknowledge back to the send buffer mention it has been successfully received the data and advertise a new receive window to the sending system. The receive window represents the number of bytes are available to receive buffer, so which means the receive window system size is 0. The sending system have to waiting to send the data until the receiving application retrieve the data from the receive buffer. The receiving system can advertise the receive window size is break to available, then TCP system will continue send the data. To conclude, the flow control is make sure it do not send over the package, otherwise it will result the error occur and system will not able to working properly and will need to drop this package. Next feature of the congestion control, which is used to avoid congestion in network data transmission. The congestion will result the package will lost in the transmit and it could not deliver complete package to receiver host. To prevent congestion situation, the congestion control will reduce the sender window size following to the receiver window size. The sender should not send data greater than the receiver window size to maintain the send buffer under control and receiver size can continue receive the data. Another one is congestion window size, which means sender should not send data greater than congestion window size to maintain the data transmission wouldn't get dropping.
The 5G small tower is essentially only a small device. The size is important is because of not only for the aesthetic, it's more about of space efficiency. Because of the smaller size advantages, it is possible to easily install all over the smart port area. Since they are small, this also could be installed in places such as on the pole, the roof of building structure, and even street lamp. So this makes it simple to implement mostly at any place within the smart port. The 5G small cells are designed to provide coverage to all areas of the smart port, regardless of their size. The antenna which has been contained among these small cells are highly directional and use a technique known as beamforming to initiate the signal to a very specific zone within the town. This method direct connection produce a stronger, faster and much more stable wireless transmission. Besides that, however, these small cells could also easily shift their power utilization according to the current load. So it means if the transmitter isn't in use, this could slide down into a lower operating state within only a few milliseconds and instead readjust itself.
There are 5 things to make a smart port achievable. The first thing is 5G, the second thing is 5G cell tower, the third is AGV, the fourth is flow control, and the final is congestion control. 5G using millimeter wave can massively increase the bandwidth, and by using massive MIMO technology, the capacity can be increased. And 5G also have beamforming technology to increase the spatial efficiency. 5G also use a full duplex system to extend the network capacity. For 5G cell tower, small cell tower can be built around the smart port to increase the network and will prevent signal loss. For automated guided vehicle AGV, this can be used for real-time sensing to control the smart port, and for the 4th and 5th flow control and congestion control, you'll be using TCP because TCP is more reliable and the data will be received in a proper order. That's all from me. Thank you.